Hello, good morning from Barcelona. Good morning to everybody from LinkedIn. I'm Dario Martino. I'm CEO and founder of DMD Solutions. And today I'm proud to present this panel, which is called Safety Challenges of Future Skies. This title is, I would like to say, every word of this challenge has been chosen in a specific way, because we would like to talk about safety, which is the core of my company, the core of my business, and practically everything I've done in my life, professional life so far. Challenges, so the challenges of what's happening above our heads in the future years. This is something that probably everybody has some ideas, which are different from the ideas of other people. So goal of this panel for me is to give you a bit the feeling of what is happening in the industry with experts in the sector. And I mean, the goal is that you go out and close, let's say, this session, knowing that there are a lot of challenges, technical challenges, but not only, because I mean, technical challenges, it's something that mankind usually solved, but especially in Europe, there is also safety barriers. And if we don't, let's say, solve properly the safety barriers, even though we close and successfully the technical challenges, we cannot go on. Okay, before starting and presenting the panelists, my friend here in the stage today, I would like to tell you why we decided to create and organize this event here in DMD Solutions. We are doing it because the aerospace industry is living a revolution. I always telling that to my employees and to my friends. There are so many innovation in the field, and there are so much changes within, respect to the traditional aviation, that being an aerospace engineer or an engineer or somebody who's working in this field today is fantastic. I mean, obviously the introduction of eVTOLs and vertiports in cities is maybe the most popular due to the new aircraft models being a symbol of modernity. But not only that, I mean, these things that flies need to be connected, so onboard connectivity. And also, unmanned vehicles of all sizes and application will do a lot of services, from transport of passengers to deliveries of goods and to, let's say, solve emergencies. Another challenge, which impacts also the traditional aviation, is the change of propulsion means. I mean, the generation of CO2 is, especially from young generation, is not accepted anymore. So electrification of changing of aircraft propulsions is needed in order to move for a future more sustainable. And also, the last but not least challenge is the integration. So all these small things or big things that will fly all together. So integration and standardization of ATM and UTM is a challenge for us and maybe for the future generation. So everything is fantastic, no? Everything looks really appealing. But first, which are the barriers, no, hindering these advances? And also, another thing is that traditional aviation is aerospace is an industry which moves slow, is an EV-regulated sector. And that's good, because the aviation is based on trust. I mean, we know that we have to minimize the number of accidents because we need the people to trust this industry. So everything, the safety and all the safety critical aspects must be considered. So which are the safety challenges that the industry is going to face? I mean, me as a safety expert, I've seen some, but probably there is some more which are not even discovered so far. And so let's say I'd like to start. So the idea for this panel is start from the vehicles, so from the things that moves, and go up towards the development of the aircraft integration, no, and the space in which these aircraft are moving. Say that, I would like to jump into the panel. So I'm presenting the people who are here with me, and very happy that you guys are here with me. I know personally everybody, and I have done a lot of discussion, maybe with some of you more than others. So I know that on much things we are on the same page. Something we fight somewhere, but that's good. So starting from my left side, Esra Seran, Director System and Aircraft Engineering at Safran Passenger Innovation. Hello, Esra. Thanks you for coming.
Good morning.
Jesús Romero, Head of Safety at ENAIRE. Hello, Jesús.
Thank you.
And here, Nacho José Igancio Rodrqiuez, Managing Director at Bluenest by Global Via.
Thank you.
And last but not least, Miquel Colom, CEO of Singular Aircraft. Good. Again, I'm really happy to be here and eager to learn from this panel. Obviously, the questions have been discussed already, but I know these people, so probably more ideas will be generated. And as I said before, I'd like to have a debate, so a discussion between us, and come out with ideas and maybe more doubts, but at least a constructive, let's say, discussion. Good. So as I said, we start with vehicles. So my first question, Esra, is for you. So I believe the industry is quite aware of safety. I would like to say that now more than 10 years ago, because I've started as a safety engineer and obviously with DMD solutions. And I want to say that 10 years ago, safety was something smoky over there. I mean, okay, there is somebody who needs to stamp a document saying that the system is safe. Now, no, there is, let's say, acknowledgement that this is something, it's a long run, so we have to start from the blank paper and go on, let's say, even after certification. So would you say that generally the safety strategy for such projects is defined from the conceptualization phase right now? What do you think? Do you agree with what I said or not? I mean, you are my client in the end, no?
Yeah. So thank you for the question, but maybe before I start, just a quick introduction where I come from the industry. I have 20 plus years in aviation, and I started in design field. So it has been like from design to systems engineering, and lately a little bit leadership roles. And I have some experience in the traditional aviation world, and as well as the eVTOL. So that kind of brings me a good view and how things work in different fields of aviation at the moment. And if I come to your question, that's a very good question, and that's actually like one of the challenges that we face as of today in different development projects. So I can say that it's an ecosystem. So it's not only the vehicle part of this equation, but I can more talk from the vehicle side since I'm more experienced on that side. So safety, I would say in the last 10 years, it kind of changed, and the requirement-based engineering started to be more the case for these kind of development programs. And when we talk about the requirements-based engineering, now safety-derived requirements are the key for this process. So in some of these organizations, this has been taken very seriously because there's a lessons learned coming from the previous projects. Even for the conventional aircrafts, the fixed wing or the helicopters, this has been part of the process. But for the new industry, which is more the eVTOLs, this has been introduced by the lessons learned. So in that sense, we have two big standards in this field. I mean, we mostly are familiar, which is one is the ARP 4754, which also DMD has a webinar on it. I also had a chance to watch it. It was great. So I really suggest everyone has a look at it. It's a good one. And there's this other one, which is 4761, which is more getting into the safety aspect aspects of this development process. So both standards have their current issues in this field, and they take the safety aspect at the very beginning of these development processes, which brings that if you want to have a reliable and a safe product at the end, which is able to fly and to get more importantly, a certification, that's important that you need to apply the safety. So it's not like a recommendation anymore. Like, it's not nice to have, but it's really a very strong field that you need to apply in your development process. So in that sense, I would say, like, it's getting better, but there is a way to go, maybe, how I can answer.
Good. Thanks, Esra. And I mean, going on, I mean, you have been involved in several highly innovative projects, and actually in some of them I've been lucky enough to be with you, no? But I have to say that sometimes I feel a certain level of skepticism about eVTOLs actually being certified. It's like, okay, they are good toys, no? Nice. It's cool to work on that. Where do you think this skepticism arises or come from?
Okay, yeah, it's one of the big questions, again, as of today. This skepticism, first, maybe like it's better to divide the question into two. Like, the one part is like the vehicle ability to fly, and the second part is the certification. So the ability to fly, as of today, there are a lot of different concepts from different organizations. And something able to fly is the less challenging part of it, because you can have your requirements limited, you don't care too much about safety, you still care, but you have a lot of limitations, you have your conceptual model, your business, and so on. So a vehicle that can fly at some point at the prototyping is something more doable, let's say. But I don't say it's easy, of course, but the less challenging. But the real challenge starts with the certification. Because with the certification, then your main aspect is safety, and you kind of try to, get into this burdens and limitations where you can really do your thing if you want to get a type certificate. So in that sense, like, the skepticism, I would say, from the aerospace professionals, or even, like, from society, is one part is reliability and safety of these vehicles and the whole ecosystem. Because even as if I think that as of today I'm not from aerospace background, I will question this, because first thing, the reason I think they're very novel and we are unfamiliar with them, because as of today we don't have them as part of our lives. So the society is questioning this, if they are safe enough, if they're reliable, like, am I safe in this environment with these are, flying over me? So that's one part, and in that sense, I think as aerospace community, we're doing a good thing, trying to market, to give the news about this industry and how this whole industry is evolving. And the other part is also sometimes when we talk about eVTOLs or this type of vehicles, we talk about them like they're very futuristic. I mean, yes, it's part of the future, but at the same time, it's not like something totally new that came, out of nowhere. So there's a big know-how from the whole aviation industry, but this bridge is somehow broken sometimes. So we kind of think like it's very, very futuristic, and there is this conventional aviation world. So maybe to kind of explain this bridge in between might bring this skepticism a little bit less. That's how I think. And maybe the last but not least is the technology, because a lot of these vehicles are using electrification. So regarding electrification now, it's not only a flight control system and propulsion system, like everything is very integrated. So before, when we were detaching the functions of a platform, we were really allocating this, like, these functions are flight control, these functions are propulsion. So as of today, it's not possible. It's basically one integrated big system, and that kind of brings also in people's mind, what is this all about? And this question is more coming from the aerospace professionals, how we decide the reliability of our aircraft architecture as of today on the hardware and software side. So yeah, that's how I can summarize. I don't know if my friends here have another decision or regarding these questions, but yeah, that's how I experience and see as of today?
Well, for me, it's important to hear the voice of Miquel here. So first of all, Miquel, introduce yourself, because I mean we are jumping into the topic directly. So
Okay, so I'm Miquel Colom. I'm MSc in aerospace engineer, and I've been working in the UAV sector for the last 15 years, designing, producing, and also operating a big system and directing a project that we call the Flux One, which is a 17-meter span UAV with 4,000 kilos maximum takeoff weight, which is quite big with the actual standards, not with the eVTOL, with the new vertical mobility systems, but if we compare with the traditional logistical or ISR UAVs, we're quite an outsiders.
okay, and so which are the most challenging point in safety assurance for such a project? Because I mean, you are really borderline, no? Because you are the size of your aircraft is really a borderline between traditional aviation, so all the problem of the traditional aviation, but also integration, no? Automatic operation and all other things. So the challenge of these future skies we want to have.
Yeah, to be in the border, and also with our concept of operation. Our idea is we're using a UAV because the pilot does not want to be there, because we want to do firefighting, we want to do logistics in our zone, we want to do sea inspection for so many hours. So our concept of operation is not a traditional one that can be inside an urbanized mobility area or from A to B every day, delivering a good from an hospital to another center. So it's always changing. That means that I don't care if from a civil point of view or from a military point of view, when we ask to prove that safety or for certification to the authority, it's always changing our operation. That means that we always avoid populated areas, but we have to prove that everything will be safe in an environment that every day will change. The fire is where it is. We cannot plan it and ask to the authorities, we will depart from that airport and we will extinguish fire in that coordinates every day. No, does not work like that. The firefighters say, today have to go here, the next day you have to go there. And probably that is the most challenging point. And also, we always have had the approach to say that what the authority says at the beginning, a UAV has not to be more than a traditional plane, but has not to be less. So we want to operate in a classical instrumental rules under ATC control. So we are not a random system that it's autonomous, that means that has kind of intelligence and things and decides things by itself. We're just following what the air controller says. Go to that heading, go at that speed, go at that altitude, and that's our idea. The challenge also came where there's no cooperative people and you have to detect, to avoid non-cooperative traffics when you are under visual rules. And now we are working a lot in what we call an automatization plan. An automatization plan means that if the pilot is not in the loop, the system has to do exactly what a pilot does. That means it has inside the autopilot the brain of the aircraft flight manual. So it means that if you are flying and the engine fails, the automatic system will follow the exact procedures that a pilot will do, because in a commercial operation, a pilot does whatever he wants or she wants. They always follow a procedure, and that's what in aviation has saved lots of lives during years, because safety, it's something that it's not a goal for a company, it's not an objective, it's a must in aviation. You have to be safe. And to be safe, not just the platform has to be safe, also the full system, the maintenance, the handling, and of course, the pilot. I don't care if it's a human or it's a machine, but it has to be safe in the same level as the traditional system has been, because our traditional pilots are real professionals and are doing their job very, very well. And we see every day, nothing happens in the skies. We have no accidents.
Mm-hmm. And I mean, probably a question that common person, I mean, a person without a background in aerospace has is, I mean, a pilot, having a human being, no, piloting a plane, for a lot of people is already something is good. I mean, I have a person there. I mean, if there is if something is going wrong, no, There's a person who can take a decision, good or wrong, no? And let's say now we have to rely on this automatic operation and algorithm, no? What do you think? How can we transmit this confidence? I don't know if it's an English word. But
Yeah. It's a very nice question. It happened at the beginning at the subway, when there was no pilot in the trains. People get a little bit scared at the beginning at Paris, but after some years, people start seeing that it's a safe system. At the beginning, what they did is just to put one person, after that 0. That probably will be the idea. I don't think it will happen in the traditional commercial operation, but for example, if you have to deliver some vaccines in a remote area in Africa, flying over no one, why do you want a pilot inside? If it's a risky area, you are the only person that is in risk, it's the one that's on board. So it will be the first step. After that, we will come to more populated areas, and after that, we will start transporting people. But people will trust in us if we prove it. And that means years with no accidents, seeing that we are doing things well. We want to be happy because the money is there, but we have to be careful in that, because just a wrong step could be a killer for the sector.
Good. Thanks, Miquel. And now I will say we step above, no? So we go out from the vehicle. So now we step into operation. And here for me, it's already a bit of unknown territory, no? And here I'm happy to have Nacho and Jesus. Nacho, for example, is doing something that for me it's like the future, no? So Nacho, I don't know, you can introduce yourself and explain what are you doing at Bluenest.
Thank you, Dario. Very happy to share my experience. I come from telecommunications engineering, but I always did all my life aerospace, and I'm very proud to consider myself now aerospace engineer. I worked many years in air traffic management, in safety, project management, aeronautical information, and then I could jump to the UTM world, which is fascinating. You know, we all have shared this dream of seeing the robots of the sky doing all these tasks for ourselves and in a safe manner. So I work in UTM platforms, and finally I had the chance to do an urban air mobility project where we had the passenger eVTOL test in several countries in Europe. And then I work in an eVTOL manufacturer also, wire harnesses, and finally I come to where I work, is Bluenest by Global Via. We are not in the airborne part, but we need to communicate with everybody, with the ANSP, ATM, USSP. Of course, the eVTOL, we need to integrate the operations. So we do vertiports. We set the foundations of this new mobility, this revolution, to guarantee safe operations, of course. So we need to, let's say, from a heliport, give a lot of intelligence and automation to enable that the procedures are totally optimized, everything is very well certified. So we're going to install in our vertiports cameras where you will secure the perimeter, of course, but you will also check that there are no birds coming, that you can even with a pan-tilt zoom camera see the eVTOL coming and check the track with the flight plan ID. So say, okay, this is the whatever Lilium coming with this airline, and to have everything under control. And we also want to give redundancy, even if we are in the foundations on the ground. It's a business that we need to take care from the beginning. We need to accumulate a lot of hours of operations without incidents, okay, to gain the social acceptance. So we need to give redundancy in the communications, not only have 5G with encryption, also have radio, sometimes last resource. So all different mechanisms of intelligence with camera, with local meteorology, because let's say the METAR or the forecast of meteo from an aerodrome 30 kilometers away is not valid for an operation of an eVTOL that is with electric propulsion. Needs to be very well taken care of, and you need to measure very well the weather and check many details that we will take care in our vertiports. Yeah.
Okay. Well, actually, you already answered to my question, which is about exactly how people can feel safe, no? having vertiports in the city with eVTOLs landing and taking off, no? So the design of these vertiports it's important to transmit this sense of safety, no, to the people and be sure that we can mitigate any scenario. Specific question: what about weather? I mean, are you believe we are going to fly in each weather condition? Which are the limitations? The same are for the traditional aviation, which actually are quite high. So for a commercial flight not to fly, it means that we need really adverse weather conditions. What do you think, Nacho?
Yes, we are working with a couple of companies that are experts in weather management, and they are working also with eVTOL OEMs. And what we are doing is we are establishing, okay, what is the weather at the moment, the forecast? We are mixing a bit. What is the reliability of this forecast? Because sometimes if it's 90%, okay, you can trust, but if it's 40, you can, okay, you are going to weigh a bit the values. And also, what we do is we do this mix of information with the parameters of the eVTOLs themselves. So a multicopter will bear or will stand much more crosswind than a wing eVTOL. Okay, so we say, okay, a Lilium can stand these meters per second, and we have a superior, we pass the threshold, so we cannot take off. So it will stay there waiting. But maybe the other one, the multicopter, we change the slots, and then you put it forward, okay? So we are going to do this dynamic reconfiguration of the scheduling according to the meteo, and also, yes. So we are mixing the parameters of the aircraft, local conditions, and the forecast values. Yes, meteo for us, I think is very important because we are looking to autopiloted operations, to automated operations, autonomous in the future. And if you don't have a pilot correct in the landing procedure, looking at the windsock, okay, I need to correct a bit here to land directly on the TLOF. So you need to have this data link telling the aircraft, okay, this is the exact weather, and you need to correct this with this 2 meters per second of wind. You need to correct 1 meter to the right or whatever. So you need to do this very advanced, with artificial intelligence also training, very advanced correction for the weather. Yeah.
Okay, okay. So you expect support also from the OEM, no, in this case?
Yes, we are working with more than 5 OEMs, so we share some values with them, and they give us the thresholds, not only for charging the batteries, I mean the curve of charge, but also exactly the maximum meters per second of wind they can bear. Yeah.
Okay.
Very important.
Can I add something?
Sure.
So just, it's an interesting subject for the environmental and the sustainability, because in today's world, in this vehicles for the design, first, as I said, it's an ecosystem. For the vehicle design itself, you always take the impact and the interface management with the infrastructure around you. So for the vehicle side, there are some fields. The environmental qualification is the key, but also this noise reduction and the battery that we use in this electrified systems. So in that sense, also I could say, like within the other players in the industry regarding infrastructure, as a new aspect today, the vehicle developers are working very in close contact, which is also supporting the idea of today. And it kind of brings the, support to your first question, this the skepticism. Exactly. So it's a good point to maybe mention here again, like the whole ecosystem is working together. So this is I think a very positive and advantage as of today's aviation. So just wanted to add it.
Good, thanks. And Miquel, I mean, probably you will not land from a vertiport, but how can you help Nacho, or how can you help infrastructure?
Maybe in the future you are vertical.
Do you foresee design for specific adverse weather conditions?
As you said before, we are always a borderline. We're always walking on the line. So we want to operate in adverse condition, but not in the classical adverse condition, which means, for example, icing condition, which will mean to put so much weight in our plane to be certified in that kind of operation. But for example, we want to operate in a smoky area during a fire. And it's challenging because we are developing technology which is over the state of the art to detect and to predict that weather after that black smoke or white smoke or gray smoke that you can find in a fire. For example, by now we are collecting air data on board when we are flying to share it with the other actors during a fire, because the difference of the gradient of the air, it's always high in the atmosphere, but in a fire condition or in a very turbulent hot condition, it's so different. So it's something that we are doing in real time, that kind of mapping of weather, but in a small areas. We're a small plane and we can help but a little bit.
Good. Thanks. Okay, so vehicle, infrastructure, vertiports. Now we go up. Now we go in the sky, no? Airspace operation. Okay, Nacho, this is also for you. As potentially drones are going to be operating in the same aerospace for delivering an emergency application, no? Can drone and eVTOLs, so we are speaking about drones and eVTOLs, safely share the airspace and how, obviously?
Yeah, sure. We are working here with ENAIRE and ATM suppliers and USSP certified companies to have this, what they call electronic conspicuity, that everybody has the same picture in their screen, and they can mix the conventional aviation with the position of the drones. We are trying to separate, different airspace levels, altitude, like very low level for the lower altitudes for the cargo drones, then helicopters and also passenger eVTOLs or bigger cargo eVTOLs, and then you will have conventional aviation, ultralight, and so on the top. So yes, we are working with different technologies. Like now, from this year in Spain, no, in Europe, it's an EASA regulation. You need to have a remote ID in a dongle in your drone saying, okay, this is my position, and it's having their independent battery. It's only 40 grams, and I'm using sometimes even 2 to have redundancy. Very safe, and it's working very well. And for more critical operations with bigger drones and near the airport, we use also conventional Mode S MSSR position, transponder, and you can use ADS-B. So it is expected that for passenger eVTOL, you will use ADS-B, also ADS Bravo. And for other drones, you use ADS-L Light, that is being also regulated now by EASA with the 860 rule, because you don't want to collapse also the air traffic controller with hundreds of data of small drones that is going to not make easy his job of controlling where he has to focus in the ATC control services. Yes.
Okay. And Jesus, now it's your turn.
Hello.
Well, I honestly believe you have the most challenging responsibility here, because you need to, everybody of us, we see exactly.
We are used to that.
We look at our part, our side, and each one of us is expert, no? You have to be expert of everything, no? And overlook the whole thing. So first of all, introduce yourself as everybody.
Okay, thank you, Dario. Thank you, DMD, for the invitation and for the panel. Yes, you are right. We are like the big brother to see and to control everyone there. So the question is how to integrate all these different vehicles, eVTOLs, drones, with the, let's say, conventional aviation. Of course, the US space is the toolbox, the tool we are going to use. We are pushing for that. But I would like to firstly kind of introduce, because we are talking here about the new thing we want to integrate with the old thing, the old-fashioned thing. But this old-fashioned thing is a very robust system, and we have said that before. Aviation is the most safe transportation in the world. So we have a lot of hard work to do that. And I can give you some examples. We can also talk about the over-regulation side. Our 373 is the regulation we had to face and to implement. Sometimes this over-regulation, it doesn't mean more safety. I mean, more regulation not always means more safety, and we have to be clear on that. And of course, some regulation is needed. But for example, I will give you some examples of the safety management system in the 373, the ATM world. For example, our day-to-day in safety operations is we had to investigate occurrences. We had defined some separation minima in different environments, in route environments, 5 nautical miles, in approach environment, 3 nautical miles. Whenever we have something, some 2 aircraft closer than that, we have an occurrence, and it's mandatory to investigate that, to make some conclusions, to put in practice some recommendations and actions. So this is already there. I mean, we need to think of what we have, and we have to integrate this with newcomers, okay? This is an example. Another activity, a common activity, is whenever we have a change, and Esra mentioned at the beginning, the safety has to be there with the change. We have to analyze maybe 800 changes per year in ENAIRE. A lot of things change in a big ANSP like ENAIRE. For example, I would like to mention in Madrid, we changed last year to parallel independent approach. So we can produce a better throughput. More aircrafts are coming and leaving the airport, and that's business, of course. But this has to be in a sure manner. No? So we can allow the 2 aircraft to come to a parallel independently. We don't need our controllers to separate those because they are independent. And this is a big safety assessment. It took us like 3 years, this safety assessment. And on the other hand, we have to analyze wherever, we talked about this yesterday, we have a change in a letter of agreement between two small units, a change in the telephone number. We had to do a safety assessment. So imagine the kind of scalability, the different ways to approach a safety assessment we had to do to keep this very safe and robust system. So just to keep this in mind and to keep this an eye on this, because we want to integrate, of course, the newcomers, eVTOLs, drones, and the US space is the tool we are going to use. But we need to go, sometimes in safety area, we say baby steps. It's better to go not so fast, I mean, to go slowly, but pretty sure, because whenever we go wrong, it's going to be harder to come back again to the path. So we need to be very, very sure with this. So our proposal for ENAIRE, and we are, of course, pushing harder for this new concept UTM, US space, is to provide, let's say, low-risk scenarios, low-risk projects, and then whenever we gain confidence and maturity on that, we can move forward to another. And I would like to mention some of the, let's say, the flagship, the most remarkable projects are, for example, you already have heard about it, is Welcome. It's a big project, more than 50 partners. For example, in Benidorm, we test with a real case in uncontrolled airspace. And we also in Coruña test Welcome project in a controlled airspace. So the answer is yes. We will sometime we have this integration, but we need to go, let's say, very safely before going, let's say, to the final aim.
Yeah, what we said at the beginning, no? We are in a sector which is heavy regulated, and I mean, trust it's really important.
That's correct.
And Jesus, similar to the question, no, the discussion we had with Miquel regarding automatic operation. Now, how much, let's say, this will be fully automated in the future, and maybe when? I know it's a difficult question, but I mean,
Well-
artificial intelligence will enter in the equation?
Yeah. There are a
do
lot
you
of
think?
factors to enter in the question. Let's talk about let's say, collision avoidance and how to maintain all the actors in their own zone, not getting very close together. For example, if we want to maintain this in a US space, in a control airspace, this is going to be a responsibility of the ATM provider, of course. And we want to use our own ATM elements. And we need to have an interface between the ATM and the US environment, and this is something we have been working on, and Gonzalo is already there, and Indra and ENAIRE are working in this platform, and we are baby stepping in the safety analysis of that. Because at the end, I mean, for the controller space, in order to provide this collision avoidance, what we do today is we have a very robust ACAS system, airborne collision avoidance in the aircraft. And we have, of course, all the safety nets providing for our SACTA system. We have our short-term conflict detection and these kind of things that provide a lot of safety in the operation. So we need to integrate this with the newcomers, and those things are not easy. I mean, for example, I give you an example. Just today, we are running a shadow mode in what we call the TTM, Tactical Trajectory Monitoring, is another tool for our controllers in order to provide, let's say, a what-if tool. Whatever our controllers is giving a clearance to a flight level, whatever, the tool, our SACTA system, is going to provide them with a kind of what-if. I mean, what happened? Do you have any conflict with this instruction or no? Because this is a current risk in our system, and this is something we call blind spot. Sometimes, because the human is the center, as you mentioned before, and we are very reliable, and we trust on our controllers, but sometimes there is a blind spot, this is a tunnel effect, and we don't see the conflict. And the machine is now going to provide us with information so we can anticipate that before giving that clearance. So this is kind of the advance in the safety. And this is all related to the integration in a controlled airspace, EU space. And whenever we talk about EU space in a non-controlled area, we have to talk about EU conspicuity and all these kind of, let's say, low-cost TCAS systems, FLARM or Aeropilot aware, and these kind of things. So these are the two scenarios, I guess.
Okay, good. Actually, you answered. I had the question, but actually you answered. No, the next one was. I mean, now airports are segregated from U space, but in the future, I mean, do we see it in everything in a centralized traffic management system?
Yeah, and we let's say the first step it would be segregated, the first initial step, but we go definitely in the environment of the airport. For this kind of dynamic automatic areas in order to reconfigure the airspace in order to accommodate both. So this is the future idea.
This is the long-term scenario, and we all agree. I think we all agree that it will come. But operatively, what use cases can necessitate from an integrated ATM, UTM airspace?
Well, I would say in the short term. Those use cases are mainly medical. I mean, medical and all healthcare urgencies of transport, and whenever we have a helicopter entering the city, so this is a scenario all related with surveillance. This is a short-term case. And if we think about, let's say, longer term, I would say, for example, we will have to integrate this in all the calibration of our NA systems. In an airport, for example, the ILS needs to be calibrated. So this is a use case for the future that we will need, that is a necessity.
Sure.
Yeah.
And Miquel, Esra, from your experience, what do you think? Which will be the? Do you agree with Jesus, or do you think there is some more that you can add?
No, I fully agree. I don't know anything about UTM or how you want to manage there, but our idea is we're integrating a TCAS2 in also an ACAS, but as close we will be to the traditional systems and to the traditional infrastructure, easier will be to be integrated in the system. After that, let's talk about autonomy, do whatever we want inside an area because everything will be safe and fully controlled and predictable. But by now, what we will do if something goes wrong, we change the transponder automatically to emergency mode, we report it to the ATC, and we follow the normal procedures for that.
There is just a point there, and I would like to mention as well is what we call the human factor, because we are a very robust system, and we have our controllers, our pilots as the main actors there. But just as an example, we have in our safety management system the management of risk coming from fatigue and stress. And this is something we had to manage. And imagine this kind of risk management in that other environment with newcomers, with new actors, very professional, all of them. But we need to go in this way in order to have, let's say, the same level of safety in these two scenarios. So it's complicated because the level we achieve already with all this kind of fine tuning in the safety management system is going to be also there in the newcomers. So just imagine the kind of things we will need to do. Of course, not in the short term, but at the end, wherever we have this integrated scenario.
Well, also in terms of training of people, no? Because now
Yeah,
the training is regulated.
Exactly. We have a lot of regulation. We have a lot of training regulation for our ADCOT, how many hours you have to do with this kind of training, the refreshment training, all kind of training is regulated, and this should be someday the same for the other actors.
Mm-hmm. Okay, yeah. And I mean, coming back a bit to the communication, no, we already touched the system, but Nacho, what do you think in the future? ATM and UTM will use all equivalent communication system to signal their position? There's something new coming, or some technology that we are not using yet?
I think we will have more competitive advanced technologies and with better prices to be able to be usable for all of hundreds of drones, especially for beyond visual line of sight medical logistics. You need to use a lighter equipment that is competitive. So we are going to use the whatever formats coming from aviation, like aesthetics, for radar and so on, but evolve them to be more digital, automated for machines, even for artificial intelligence machines to swallow all this information, keeping all the actors integrated and consistent, of course. Yeah, I think we are starting from the available technology, but like ADS-B to ADS-L, we are evolving to lighter technology that we can integrate into thousands of drones to do their job. Yeah.
Good. And now, I mean, Jesus, you already touched this base. Yes. So regarding regulation of the safe and efficient infrastructure, which actually
Nacho.
Considers all the scenarios.
Nacho, you go first and go later. No, because talking about regulation, I would like to mention, because it's something that is kind of news these days, is the new royal decree here in Spain, on US. Fortunately, we have
some years in the oven. Eh?
So fortunately, the new royal decree is there. Just to mention that ENAIRE is designed as the common information service provided there. So we are going to go for it. We need, after this royal decree entering into force at the end of June, then we need to go for the certification of the CISP and later for the USSP as well. So this is a kind of important thing because it's another, let's say, baby step in the regulation, and this is something we have been waiting, and it's putting more flexibility in the, let's say, drone operations, in the normal drone operations. Nowadays, wherever we have an operation of a drone in a controller space, we need, let's say, coordination, and with this new regulation is more flexible. It's easier for the operator to run the business. So that's good with all the safety warranties, of course. But this is let's say a good step in terms of regulation. So and it's here in Spain, but we are here in Spain, so I had to mention that.
No, for me it was very important that AESA was very active in improving and regulating with EASA at the European level. And now finally with the new royal decree, we are at this level to be able to use all these progresses that we helped to. And I think Spain is very advanced in general in everything. Many companies working in the drone sector. The leaders in UTM, being probably the first certified USSP and CISP in Europe, okay, here in Spain. And many more advances also in regulation. Finally, now we can fly in the Welcome project, where we fly in the hospitals in Madrid. Before we needed to call the Barajas airport, because we were there 8 kilometers apart, and bother the controllers, with a drone that is flying 40 meters AGL. So now we don't need to do these things to take the ICOM. We were talking yesterday about it. It's, like you say, they need to be focused with important things, not with everything and get blind spots because they are busy with other things that will be automated. And we need to believe in automation. I believe that when I work in safety some years, 70–80% of the failures and accidents came from human intervention. So if you have good procedures that are being done by humans, you have good software that is supervised by humans, in the end you put it into a lot of hours of operation, you test it, and then you gain statistics, and you gain confidence, and then you let it run, and you supervise. But we cannot control thousands of drones, and we need to even let the autopilots work, and then just be there if it's needed for an alert or something.
Good. Okay, we are going towards the end of this panel. So I would like to close. The last subject is about talent. So there is, obviously, we have seen that safety is of paramount importance to overcome all these barriers. And now, in the following years, there will be need of experts in these areas. And I mean, not only experts, but also people that first know the methodology, but also have seen projects. Because I mean, safety expertise relies on how many times did you fail. So how many failure have you seen? So I personally see that there is shortage of these figures nowadays in the industry, and I don't know if in the future will be like that. So my question for everybody, and I mean, I ask you to be quick on this, is how do you believe our sector will overcome this shortage of expertise? I mean, in my case of safety, because this is my territory, but in your specific areas of industry. I don't know if you want to start.
Sure, I'll try. So, I mean, what to do about it is the hard question, because there's no like magic formula and then you have 100 more safety engineers. But I can say like safety is one of those topics as of today. We have a lot of lessons learned that it impacts cost and schedule a lot at the end of the aviation program. So if you don't take care of safety at the very beginning, you pay it with your cost and schedule at the end because you don't have the reliable system to pass and get the certification. So in that sense, I would say safety is very on demand. So that's why like a lot of organizations are looking for safety expertise at the moment. So what I can say to young people in aerospace business here, like it's one of those areas I see a huge growth. So it might seem a little bit like, I'm an engineer, it's very document-based, it's very boring, and Like I hear this a lot, but it seems like a very niche subject, but now it's dedicated to the overall life cycle. So that's why I say this is one of the evidence that shows it already. I can pass to someone else who
Jesus?
wants to contribute.
Yeah, totally agree with Esra. I mean, there is a big challenge here, and we have been talking about it, but it's a great opportunity. I mean, we all need new engineers because the business is growing, the opportunity is there. So I would say for young people, this is a great opportunity. Go for it. It's a kind of piece of advice. You need to go there because this is the future, I would say. You want to work in something, let's say, very modern, something that is going to be growing a lot. This kind of business, this kind of unmanned aircraft, how to integrate it with the ATM world is definitely the place to be, and you need to go there.
As you see, we're getting old, so please, young people, step forward, help us.
We need some support, yeah.
There is a lot to do. So it's beautiful, and we are all happy to pioneer this industry. We are creating the future, the revolution of the air mobility. So I think we need more specialization. Sometimes I don't need an aerospace engineer of 5 years to pilot a drone, or I prefer a SORA expert to do the permits to fly. So I would ask these masters for UAS, for regulation, for safety even, to be half a year, 1 year. I don't think young people have enough patience at the time now using all the day Instagram, TikTok, and so on. So if they want to specialize and focus, for me, it's fine. Sometimes I don't hire the aerospace engineer. I see that I go for the guy that did a master of 6 months that is fitting the purpose. Yeah.
Miquel?
I always recommend a book from NASA that it's called What We Learn from Our Crashes. It's a book that, after the lots of crashes that NASA has, teach the people how to do things. And the most amazing part of our sector, I think it's offering not just the skills to the people that wants to be in. It's a sector that it's looking for know-how, and it's really important. A skill, the tool could change and you are nothing. If you have know-how, you will always be someone in the sector, whichever sector is.
And from my side, I mean, if you can add 15 seconds, for me, super cool being a safety engineer because I've seen so many things in my life. Again, I don't believe I'm super old, but when I go to fairs and events, I know everybody. It's like a big family, so it's cool. It's cool. Well, I don't know if you have time for questions from LinkedIn. One question. Okay, question for the development of UAV. Pilots prove themselves to avoid accident by following emergency procedure that they are trained for and available in the AFM. But pilots also achieve this by acting not following the procedure, either because the follow scenario was not foreseen or because deviation from the procedure was deemed necessary for safety. How will be addressed in UAV design? I mean, this is for two. From Daniele Guerci. From Volocopter.
Yeah, of course we have designed these procedures having professional pilots in our team, and we call it like the last stack of our system is the controlled crash. So if the pilot has to avoid it with all the conditions, what will be the less risk for the people, air and ground risk. It's close to what the pilot will do. But like a Tesla had the issue, if you have to brake, what will hit you first? A pregnant woman or a kid? There's something that it's not easy to answer, and a computer cannot do it. Even a person cannot do it. But our goal is always to reduce risk, air and ground, to be as less catastrophic as possible.
Well, I expected this question from Daniele, actually. So good. Okay, guys, I think there are more questions, but we don't have time to answer. Thank you very much, guys. It was great, really, to have you here and to discuss. Thanks for all the people who has followed us on LinkedIn. And stay tuned with DMD Solutions with more events. Thank you very much.